In this third part of the video, we are going to look at loudness, volume of sound or sound level. This is what we talked about doing the project on the sound level meters on our phones. Let me give you a little background on sound level. The sound level is measured in a unit called the Bell, named after Alexander Graham Bell. They dropped an L off of it for some reason. It turns out a bell is way too big a unit for sound level because sound is actually a very small change in the air to cause a pretty loud sound. So the decibel is more common, and that's abbreviated lowercase d, uppercase b, since it's named after a person. And this scale is logarithmic. So let's look a little bit at the scale over here on the graphic. The important thing to remember here, because we always have trouble with this, the threshold of hearing means you can hear at the threshold of hearing. So 0 decibels is defined as the softest sound you can hear. If it's 0, you can hear it. If it's below 0, you can't. So then as we go up 10, 20, we're not talking about 10 times louder and 20 times louder. We're actually talking about going up by huge factors. So the whispering is not just 20 times louder than the softest thing you can hear, but rather way more than that. If you're out in the country where there's not much going on but nature sounds, that's going to be around 30 decibels. If you're in the living room without the TV on, just normal noise in the house, 40, in your neighborhood 50, talking to somebody 60, inside a car 70, a truck or a heavy truck. By the time we got up to 100 decibels, basically the rule is anything over 80, that if you're exposed to it for a long time, it can do damage to your ears. So people who use a jackhammer hopefully have the sense to wear something that deadens the sound. And by the time we get up to 110, 120, we're talking about doing serious damage to your hearing in a short time. And by the time we get to about 130, then it actually hurts to hear that, and maybe you've experienced that. So here's a little bit about how the logarithmic scale works. That's why I was kind of vague about it before. So 0 decibels is the softest sound you can hear. That means the pressure varies by about 2 × 10⁻⁵. That's 2 100,000ths of a pascal of pressure causes a 0 decibel sound. Remember that we are talking about compressions and rarefactions of the air. The difference between those is only 200,000ths of a pascal of pressure, which is very small. And then 10 times more pressure than that variation is 20 decibels. It's not 10 decibels because the whole decibel thing throws us off. So notice the difference between these is this is 10 times more pressure variation at 20 decibels. And then 100 times would be 40 decibels. That again is 10 times more pressure variation. So it's said on one of the videos we watched the other day that if you had a pressure variation of the pressure inside of a bike tire, it would destroy your eardrum. And now you can see why. That 40 decibels, which is like the sound in your house, is a very small pressure change. So if you had a pressure change that big, it would do serious damage to you. Okay, and we have one part left to go.